This lesson is titled Function Operations. In this example, we're going to add and subtract some functions. We've got f of x equal to 3x plus 8 and g of x equal to 2x minus 12. We are asked to do a couple of things. We're asked to take the f function and add to it the g function, and we're asked to take the f function and subtract from it the g function, and then find their domains. In other words, what can x be after we do that? So here it goes. All right, f plus g of x is the same as taking the f function plus the g function. Notice the notation here. This is just notation. Notation is how we write things. This notation means the same thing as f of x plus g of x. Well, f of x is 3x plus 8, so we can just replace that with 3x plus 8. G of x is 2x minus 12, so we can replace that with 2x minus 12. And that's just a matter of combining like terms. We have the x terms, which are the same, the 3x and the 2x, and we have the constants, the 8 and the negative 12. So 3x plus 2x is 5x, and 8 minus 12 is negative 4. So that is f plus g. The domain of this function is, since this is a nice linear function and we started with two nice linear functions, would be all real numbers. F minus g of x is the same as f of x minus g of x. So we'll take 3x plus 8 minus 2x minus 12. 3x minus 2x is 1x, and 8 minus a negative 12 is 20. Again, we start with two linear functions that have domains of all real numbers. We combine them with subtraction. We have another linear function. Its domain is also all real numbers. These are properties or definitions, actually, of function operations. The notation, this is pretty much about notation, really. F plus g of x is the same as f of x plus g of x. F times g of x is the same as f of x times g of x. F minus g of x is f of x minus g of x, and f divided by g of x is the same as f of x divided by g of x, provided that g is not 0. Can't divide by 0. A composition of functions. A composition is like when you combine two things, mix them together. This is a composition of g of f of x. Our book and other books you'll study after this year use both forms in the notation here. I prefer the one on the right, g of f of x, because it's real clear that we're taking the f function and putting it inside the g function. This function means the same thing, g of. Notice that's not a times, that's a little kind of an O symbol or circle. G of f of x means the same thing as g of f of x, where the f function goes inside the g function. We can do a lot of things with this. Let's take a look at some examples here. Here's a couple of functions. F is 3x plus 5, g is x squared. We're asked to do the operations. So let's pull all these problems up and then we'll just work them here real quick. So it says find f plus g. Well, f plus g would have to be 3x plus 5 plus x squared, which I would probably write in standard form. X squared plus 3x plus 5. There we go. F minus g, well, we're going to be subtracting g, so we could just say that's negative x squared, and then here's the f function, 3x plus 5. F divided by g, well, f is on the top, 3x plus 5. G is on the bottom, x squared. There's really not much we want to do with that, so we'll leave it alone. F plus g of x, well, that's the same as number 1. So we would have the same answer as number 1, because number 1 was f plus g. It's just that other notation. Number 9 and number 3 aren't quite the same because they're turned around. Number 3 was f minus g. Number 9 is g minus f. So we'd start with the g function and subtract all of the x function. Make sure you subtract all of it, not just the 3. So that's x squared minus 3x minus 5. And then finally, number 11 is f of g of x, f divided by g of x, which is the same as number 5. So we could just say that's the same as number 5, 3x plus 5 all over x squared. If you need more time with those, go ahead and press pause, otherwise we're moving on. We've got two more functions. G of x is 2x, h of x is x squared plus 4. We're going to evaluate each expression. Let's bring those up. These are composite functions. On number 23, they want us to find h of g of negative 5. I like to use the other notation, so that's the same as h of g of negative 5. So what we're going to do is we're going to find g of negative 5 first. So that's like I'm putting a negative 5 into the g function and see what I get. Well, that's negative 10. I can see that. Now I'm going to take that value and put it into the h function. So if I was writing all this out, I'd say g of negative 5 is negative 10. So I replace the g of negative 5 with negative 10, and now I do h of negative 10. Well, if I put negative 10 into the h function, I get 100 plus 4, or 104. Let's do 25. That's the same as g of h of negative 2. So we're putting negative 2 into the h function first. So if I put negative 2 in here, that's negative 2 squared is 4, plus 4 is 8. Now put that into the g function, and I'll get 16. Number 27 is g of h of negative 1. Let's find h of negative 1. Here's the h function. I put negative 1 in. Negative 1 squared is 1, plus 4 is 5. Now put that result into the g function. 2 times 5 is 10. And then finally, let's do number 29. h of 2. We can actually do this. That means h of 2. That says put 2 into h and see what you get. Well, if I put 2 in, I get 4 plus 4 is 8, so I just got 8 for h of 2. Now it says put 8 into h. Well, if I put 8 into h, I get 64 plus 4. That is, what, 68? And there we go. Again, if you need more time with these, press pause. Okay, for this U-try, we've got f of x is 3x squared plus 2x minus 8. G of x is x plus 2. And we've got to perform some operations and find domains. Remember, domain, you can think of that as just all the possible values that x could be. So let's just look at the domains of the functions we have here. This is a parabola, and we can plug any value of x in for the parabola. So the domain there would just be all real numbers. This is a line, and we can plug any value of x in for that line. So the domain there would be all real numbers. What do we have to watch out for? Well, we have to watch out for getting a 0 in the denominator. We can't allow that, or a negative number in an even root. We can't allow that. Well, we don't have either case here, so we're just basically looking at all real number cases there. So let's see what problems we're going to be dealing with here. All right, we'll do these, and then we'll deal with these later. So we need to do the opposite of f of x plus 4 times g of x. Well, let's just work through this piece at a time. The opposite of f of x, well, that would just be negative 3x squared plus, actually minus, because we got to do the opposite here all the way through, minus 2x plus 8. Plus 4 times g of x. Well, let's just quadruple that here on the fly. 4 times x plus 4 times 2. Now just combine like terms. I'd have a negative 3x squared, I'd have a plus 2x, and I'd have a 16. So there's the opposite of f of x plus 4 times g of x. Done. Number 53. We're going to take f of x times g of x. So we've got this 3x squared plus 2x minus 8. We're going to multiply that by x plus 2. I'm going to distribute, but I'm going to kind of go the other direction here because I think it's easier to distribute 2 things than 1 and then 3 things. I know it really doesn't matter in the long run, but so I'm going to take the x first and then the 2. So x times 3x squared is 3x cubed. X times 2x is 2x squared. And x times negative 8, negative 8x. And now the 2. 2 times 3x squared is 6x squared. 2 times 2x is 4x. And 2 times negative 8 is negative 16. Let's go ahead and add all this up. 3x is cubed plus 8x is squared minus 4x is minus 16. So there's my result for number 53, f times g of x. And then finally, number 55, we're just going to do f divided by g of x. So I've got 3x squared plus 2x minus 8 over x plus 2. We need to check this and see if it reduces. And just a quick check looks like it will, because if negative 2 is a 0 of this, then it should factor. So let's go ahead and try that. If it's going to reduce, there'll have to be a factor of x plus 2 in the 3x squared plus 2x minus 8. So if I have a 3x squared here and an x there, I'd need a 3x there. If I have a 2 here and a negative 8 there, I'd need a negative 4 there. So let's just see if that would give us that trinomial. 3x times x is 3x squared, yep. 3x times 2 is 6x, and then I'd have a negative 4x that gives me the 2x, and then negative 4 and positive 2 is negative 8. So that does factor in, and we'll reduce that down. So our final answer on number 55 is 3x minus 4. Now, we haven't done any domains here, so let's go back and do the domains. The domain on this first one, we got a nice parabola. The domain of parabolas is all real numbers. The domain on the last one, we got this nice linear function. However, we have to make sure that we don't divide by negative 2. I know we didn't end up with that, but we want to make sure we don't divide by negative 2 along the way so that this is actually makes sense and is defined. So for this one, we would say the domain is x cannot be negative 2. We don't want that division by 0 here to happen. Number 53, we've got this cubic. Most cubics have a pattern that goes something like this or like this. They do get wider both left and right, so it'll cover all x values, so the domain there is all real numbers again. A couple new functions, f of x and g of x. We've got a small parabola or quadratic equation and a nice little line here. Find the value of each expression. We're doing composites again. So let's do g of f of negative 2. So in my head, I'm actually seeing g of, actually, let's see a g there. G of f of negative 2. G of f of negative 2. So I put negative 2 into the g function. That's over here. That gives me negative 5. And I take that value, put it into the, actually, let's do this right. I put negative 2 into the f function. I got to do what this says. This says f of negative 2. So I go find the f function. I put negative 2 into that. That's 4. Now I take that result to the g function. 4 minus 3 is 1. So that equals 1. Let's take a look at 33. G of f of 0. So I'm going to do f of 0. F of 0 is 0. Take that answer, put it into the g function. 0 minus 3 is negative 3. Let's go ahead and look at number 35. G of f of 3.5. Well, f of 3.5, 3.5 squared. 3.5 squared is 12.25. We put that into the g function. 12.25 minus 3 should be 9.25. Number 37, f of g of a half. Well, g of a half, let's see, we have 1/2 minus 3. That would be negative 2.5. If we take negative 2.5 and square it, plugging that into the f function to square that, we would get 6.25. And then f of g of c. Now this is a little more interesting because we're actually not putting a number in now. We're actually putting the c value in. So let's do that. F of g of c. You might want to write this down instead of trying to do so much in our head. So g of c, well, if I put c into the g function, I would just get c minus 3. So I've got f of c minus 3. And if I put c minus 3 into the f function, one form of that would just say that that's c minus 3 squared. And we're good. Let's do f of g of negative a. Well, f of g of negative a. Putting negative a into the g function, so we're going to stick a negative a right there. We get f of g of negative a is negative a minus 3. And now we're going to put that into the f function, which means we're going to square it. So we're going to have negative a minus 3, and we're going to square that thing. How's that? That's our learning target for this lesson. I'll see you in class.